Hi everyone. In this video I'm going to talk about the basics of multiplication, leading us into thinking about multiplication as area. I'm going to begin by talking about multiplication as repeated addition, which is how a lot of us think about multiplication. So for instance, if we have this row of 4 hearts, and we add another row of 4 hearts, and another row of 4 hearts, we can think of this as 4 plus 4 plus 4, which is 12. Or we can think of it as 4 times 3, because we've repeated the 4 3 times, and that's also 12. But another way to think of this 4 plus 4 plus 4, or 4 times 3, is if we think of these as rows and columns. So we can think of this as 1, 2, 3 rows of 4 hearts, and that's our 4 times 3. Or we can think of this as 1, 2, 3, 4 columns of 3 hearts. And that's another way to think of multiplication, as rows and columns. So if we think of multiplication as rows and columns, this leads us to another way of thinking of multiplication. So we can think of multiplication as repeated rows or columns, but also as area. If you look, this is a box. It has the hearts in it from before, but now it's in a rectangle. Here I've written the rectangle over again, but smaller. This is a 4 by 3 rectangle. So just before, where we had 4 hearts going across and 3 down, now I have 4 boxes going across and 3 boxes going down. And you can see that there are 12 squares inside the rectangle, and that's the same as the area of a rectangle. So in other words, 4 times 3 equals 12 can be thought of as the area of a rectangle. So now I'm going to show you how to do a larger area to make a larger multiplication problem, and going back to our base 10 blocks that we used for addition and subtraction. So I want to make a 23 by 14 rectangle here. This rectangle that I have here is bigger than 23 by 14. I want to mark out exactly 23 going across the top, and then exactly 14 going down. So to do that, to make it easier on myself, I'm going to count the boxes going across, and I'm going to mark out every 10 boxes so that I know when I get to 23 a little easier. So I counted out 10 and going across. So that's 1 box, 2 boxes, 3 boxes, and so on until I got to 10 boxes here. And now I'm going to count out another 10 boxes. So here's another 10 boxes going to here. And then I need 3 more to make 23. 1, 2, 3. So this is 23 boxes going across the top. And now what we want to do is we want to make 14 boxes going down. So you can count, you've got to count this first one here, and then count all the way down 14 boxes. So here I've counted out 14 boxes going down and colored them in. Now, just to be clear, we want to color in the whole rectangle. We're making a rectangle here. And so we count out the squares going across and down, and then color in the whole rectangle. So now we have a 23 by 14 rectangle. And I'm just going to keep the mark out of where the 10 is, and then 4 more to make 14. Just like I've counted out 10, 10, and 3 up here. Now our challenge. Can you fit a base 10 flat into this area? Remember that a base 10 flat is a 10 by 10 flat. So pause the video for a second and imagine, see my mark off by 10? That's why I did that. Imagine where a 10 by 10 flat would go. And then imagine where another 10 by 10 flat could go, because you can actually fit two 10 by 10 flats in this rectangle. So pause the video for a second and see if you can see where they fit. So here's one 10 by 10 flat that I could fit in. And now see if you can fit the second 10 by 10 flat in next to it. So here's the second 10 by 10 flat next to it, and I colored it a different color. And now you might be able to see where some rods could fit in. Remember that rods are 1 by 10, and see if you can fit some rods in next to the flat and below the flat. Remember that rods are only 10 high or 10 long. Pause the video for a second and see if you can count how many rods you can fit into this picture. So hopefully you were able to see that here's a rod that you can fit into the picture. And then next to it are two more rods that you can fit into this picture, but that you can also fit in rods below that over here. So let's count how many rods we can fit in all together, and I'm just coloring them different colors so you can see them better. But here's another set, another rod here, and below it are some more rods. So another rod here, another rod here, and so on. So I've now colored in all the rods that we have. Notice that we have 3 rods here and 1, 2, 3, 4, 5, 6, 7, 8 rods here. Those are going to show up in a minute as I show you how to pick apart this problem. Then what are these that are left here? These are units. So this is a 3 by 4, right? And 3 times 4 is 12. That's 12 units. So where you can see these flats, rods, and units is if you break apart the 23 times 14 into 20 plus 3, which is what we did going across. We did 20 and then plus the 3, and then times 10 plus 4. And if you use the distributive property, you can see all of the rods and flats and units show up. So, for example, 20 times 10, that's 200. And that's 2 flats. There's our 2 flats. And then we do the next distributive property, which is 20 times the 4. You can, if you do this in a different order, that's fine too. But 20 times 4 is 80, right? So 20 here times the 4 here, that's 80. And where do we see 80? 80 is in the 8 rods that show up down here. Next thing to do is 3 times 10, that's 30. Where do we see 30? 30 is in the 3 rods that show up here. And finally, 3 times 4 is 12. And that's in the 12 units that show up here. These are called partial products, and all the partial products show up in your picture of your area. The key to doing these area problems correctly is to make sure that you start by making your rectangle first. And so if I ask you to do a 23 times 14 problem, make a 23 across by 14 going down rectangle before first, and then start coloring in the flats, rods, and units. So I hope it's fun. I think it's an eye-opener that this is where all the pieces, where you can see all the pieces of a multiplication problem.